coming back to section 7.1, so I asked you to try doing the part D, verifying identities. So here are a couple of ways. There are again several ways you can do this type of problems, but let us see some simpler methods or quicker, the way we can quickly show or verify the identity. So I start with the left hand side, and I always start by writing the left hand side or right hand side with which I am going to work. So here is just the common, the given expression, and then I work with this. Now, often students or some teachers, even they start over here, they will like LHS and they will start here, which is okay. If you want to do it like that, that's fine. But I always write the side or the equation that I'm going to work with. So left hand side is given here, so I'm now converting everything into sine and cosine. So secant is 1 over cosine, secant is 1 over sine, and then inside tangent sine of x over cosine of x plus cotangent is cosine of x plus sine of x. Cosine of x divided by sine of x. And now I can do it again. There are several ways to do it. So what I did now, I distributed this quantity which is written outside the parentheses inside. So when I multiply this term by 1 over cosine x, so I am getting 1 over cosine x times 1 over sine x times sine of x over cosine of x. So note here that the sine of x and sine of x get cancelled, and I have 1 over cosine x into 1 over cosine x, which gives me 1 over cosine square x. So that's what I wrote here. And similarly, when I distribute this quantity 1 over cosine x into 1 over sine x with cosine x over sine x, then cosine and cosine cancel out and we are left with 1 over sine square x. So this is how I got here. And now if you note, 1 over cosine square x is secant square x, and 1 over sine square x will be secant square x. So we got our right hand side. Now it might happen that after reaching this point, someone that doesn't recognize that this is secant square and the other term is cosecant square. Because remember, you should keep an eye on your goal, right? You should keep an eye on if you are starting with the left hand side, keep an eye on the right hand side where we are going. So anytime you feel like you are at any step, the expression that you got can easily be written in terms of the other side, then just do that. Otherwise, if someone doesn't recognize that, then you could do this. You could take the common denominator, and your numerator will be sine square x. So from here, take the common denominator, which is coming to be sine square x times cosine square x. Top sine square x plus cosine square x, which is 1 over sine square x times cosine square x. So you might now compare it with the right hand side. Well, right hand side has a plus sign in between, and we have this product sign here, and also this is in the denominator. So they are not equal to each other. So you cannot just say here no, the identity is not correct, because you are not being asked to check whether the identity is correct or not. You are being asked to verify. So which means the identity is correct. You just have to show why it is correct by doing your steps. So you arrived here, you say, okay, I arrived here, but this is not looking like my right hand side, so let me see what I can do with the right hand side. So now you take the right hand side and try to write that in terms of the cosine and sine, and then go from there. So you will end up getting what I have here. So you see these two terms are same. So you can say now left hand side is equal to right hand side. So you have proved that the identity is true, or it is verified. Okay, let's move on to the next one. Now, by the way, there is another way to do this problem. We could have done it this way as well. So the left hand side, secant x times cosecant x secant x times cosecant x times sin x. Okay, times tangent x plus cotangent x, right? So this is our left hand side. So what you can do is convert everything into sine and cosine as before. But now instead of distributing, we can simplify the quantities inside the parentheses. So we can write as 1 over cosine x into 1 over sine x times a common denominator, which is cosine x times sine x, which gives me sine square x times cosine plus cosine square x, so that we get at the bottom 1 over cosine x times sine x times 1 over cosine x times sine x. So this also gives you 1 over cosine square x times sine square x. But again, this is not what our right hand side is. So if you arrived here, now you should pick up your right hand side and do what I just showed you on the left here, and you should be able to show that the two sides are equal to each other. Looking at the next one. Now again, this can be done in a couple of ways. So which one is looking harder? I think right side might look hard, because on the left side it's like something missing, like it's not giving us a hint what to do, but right hand side is telling us to just like find secant of t minus tangent of t whole square, which means take 2 copies of this expression and then multiply them out. So but remember one thing, we have the sine square t plus cosine square t is equal to 1. So from here, sine square t is equal to 1 minus cosine square t, and cosine square t is equal to 1 minus sine square t. So these are something that you should remember. Okay, so here let's say we start with the right hand side. So I will have secant t minus tangent t times secant of t minus tangent of t, which is equal to secant square t minus secant of t into tangent of t minus secant t into tangent t plus tangent square t. So this gives us secant square t minus 2 times secant of t into tangent of t plus tangent square t. Now remember, secant square t plus tangent square t is not 1. Remember our identities, if you recall. So the Pythagorean identity with secant and tangent was tangent square t plus 1 is equal to secant square t, which means if I have secant square t, I can replace it by 1 plus tangent square t. Or from here, if you note that tangent square t will be equal to secant square t minus 1, or 1 is equal to secant square t minus tangent square t. So these are the other forms of the same identity. So any place you see secant square t, you can replace it by 1 plus tangent square t. If you see tangent square t, you can replace by secant square t minus 1. Okay, so if I replace the tangent square t by secant square t minus 1, so what do we get? So this gives us now this and this gives us 2 secant square t, and then we have minus 2 times secant of t into tangent of t minus 1. And this doesn't look like our right hand side. But note here on the right hand side we have sine t. So what should we have done? We should have converted it into sine and cosine first, and then should have done the operation. Can we do it now? Can we convert it into sine and cosine now? Yes, we can. But it will be better if we do it from the beginning. So this is like, okay, where are we now? So we go back, rewrite my secant of t. So this is secant of t minus tangent of t whole squared. So I'll write it like 1 over cosine t minus sine t over cosine t whole squared. But if you notice the inside here in parentheses, the denominator is same, so I can write it as 1 fraction. So will be equal to cosine t, and I have 1 minus sine t whole squared. Okay, so so in the left hand side, if you notice, there is a 1 minus sine t on the top. So we have here 1 minus sine t, but we have 2 copies of it. So what do? We can write is now 1 minus sine of t into 1 minus sine of t whole divided by cosine square t, or cosine of t times cosine of t, cosine square t. Now from here I can replace my cosine square t by 1 minus sine square t. So I have on the top 1 minus sine t into 1 minus sine t, and the bottom is 1 minus sine square t. Now we can apply the formula. A square minus b square is equal to a minus b times a plus b. So on the top I have 1 minus sine t into 1 minus sine t. The bottom will become 1 minus sine t into 1 plus sine t. So 1 minus sine t and 1 minus sine t, one of them cancels out, and we are left with and which is equal to the left hand side. So we are done. Now another way of doing this is I will show you here. So another way of doing this one is, or if you start with the left hand side, which is 1 minus sine t over 1 plus sine t. So if you can remember these, some algebra and some of these identities, remember if we have a square minus b square, that is equal to a minus b times a plus b. So if I have 1 minus sine square t, I can write it as 1 minus sine t times 1 plus sine t. So what I can do here, because we can multiply top and bottom by 1 minus sine t. So the top becomes 1 minus sine t whole squared, and the bottom becomes 1 minus sine square t, which is equal to 1 minus sine t whole squared divided by cosine square t, which can be written as 1 minus sine t over cosine t whole squared. And now if you divide both on the top by cosine t, we get 1 over cosine t minus sine t over cosine t whole squared. But the first one is secant of t and the second is tangent of t. So equal to secant of t minus tangent of t whole squared. And that is what we have on the right hand side. But this is something maybe not many students will get that, but at least you should know the other way. Now looking at the next problem, which is the last one here. So we have left side is looking complicated, so we will just start with the left hand side. Okay, so remember, whenever you have two fractions being added or subtracted, the first thing that should come to mind is common denominator. So here if I do the common denominator, sine of t into 1 minus cosine of t, and then it will be on the top we get 1 minus cosine of t whole squared plus sine square t, because the top here will become sine of t times sine of t. So now I expand the first one, so I get 1. So I have to go on a side, and if you remember the formula, you can do it directly. Otherwise, you have to have 2 copies of 1 minus cosine t and 1 to 1 minus cosine t and multiply it out. You get 1 minus 2 cosine t plus cosine square t, and then plus sine square t. Whole thing divided, sorry, there was a 2 I am missing somewhere here. 2, 1 minus 2 cosine t plus cosine square t, and then plus sine square t, and at the bottom I have sine of t into 1 minus cosine of t, which is now equal to, so on the top there I get 1 minus 2 cosine t plus 1, because cosine square t plus sine square t is 1, whole thing divided by sine of t times 1 minus cosine of t. Now some students would say, oh, if you cancel like this and this, that is wrong. We cannot cancel at this time. The top becomes 2 minus 2 cosine t, bottom is sine t into 1 minus cosine t. So now you can factor out the 2 from the top, so you get 1 minus cosine t, and at the bottom still sine of t times 1 minus cosine of t. So now you can cancel this factor with that factor, so you are left with 2 over sine of t, or 2 times cosecant of t, which is what you had to prove. So this is equal to right hand side. So this is how we do these identities. So you need a lot of practice. So here are a bunch of problems. Some of them I have assigned as the next hand in homework. Now the reason you could see that this assignment is not given for an online homework, so the hand in homework is the one that I will be checking and grading for this one section. Okay, we will now look at section 7.2 in the next video.